Okay, so we're going to get to today's activity, which is write an equation for a polynomial function that will also include an a value or the stretch factor. The first thing we want to do is determine the parent graph. So you look at the graph here, and then you look at those graphs on the other page, and you see that it's an x cubed graph. So it looks kind of like an N or a sideways S. Those are x cubed graphs. Number two is to find the x-intercepts. We got them right here and over here. So one of them's at 2, 0, the other one's at negative 2, 0. The next thing we're going to do is write this in factored form. So that means taking our intercepts and putting them back in their original parentheses in the equation. So in our case, it's going to be y equals a times x plus 2 times x minus 2. So the negative 2 goes with the plus 1, because if I were to undo this, I would have to subtract 2. And the positive 2 intercept goes with the x minus 2. Okay, so the next step is to multiply this out here just in your head and verify that it is becoming a x cubed. And in our case, if we take x times x, we get x squared, which means that it is only a degree 2 polynomial, and we need a degree 3 polynomial. So one of our terms here is squared. The way to determine which one is squared is to go look at the graph and see where the curve is bouncing off of the x-axis. So this intercept over here, the curve goes through it. It doesn't turn around, if you will. This one goes straight through from the positives into the negatives. So we want to look for one that's going to turn around. And that turns out to be this one over here. So as the curve's coming down here, it hits the x-axis, bounces off of it, turns around, and goes back in the upward direction. So this intercept is negative 2. Negative 2 goes with the x plus 2 portion of our equation. So that's the term that's squared. We rewrite the equation. We get y equals a times x plus 2 squared, and then x minus 2. So if I were to multiply these out, sure enough, I would have 2 x's here from the squaring, and then a third one here. So now we have our degree of 3. So the next thing we're going to do is find the a value. To find the a value, we need to take a point that's on the graph that is not one of the x-intercepts. And a lot of times the best thing to use is the y-intercept. So in this case, here's our y-intercept, left, right, nothing, up 16. So my y-intercept is 0, 16. I plug the 16 into my equation. 16 is the y value. So 16 equals a times 0 plus 2 squared times 0 minus 2. Do some simplification, and we can see that 4 is over here. 0 minus 2 is negative 2, so that turns out to be negative 8. And then if I do my division, a is negative 2. So finally, I take my negative 2 and plug it into my original format up here with this right here, this one, the rewrite one, number 5. And so my answer is y equals negative 2 times x plus 2 squared times x minus 2. You could always use your graphing calculator or Decimals.com, plug that in, and verify that, in fact, it looks like the one shown over on the right. So that is how you write an equation for a polynomial function that includes its stretch factor.